People can use different types of materials to create paintings. Prehistoric people in Europe used charcoal, blood and soil. Renaissance painters used handmade oil. Today, Banksy tends to use spray paint can. But what if I tell you if there is more peculiar method to create art? Actually, it allows every microbiologist to become an artist. As we make significant progress in studying bacteria, we can understand their motion mechanism better and better. Therefore, we can use bacterial needs for nutrient as a source of painting material. Check this out. Bacteria prefers to move towards their food source. This phenomenon is called chemotaxis. So let's choose the type of bacteria for which it is very easy to control their food source. For example, Cyanobacteria. In case of Cyanobacteria, the food source is light. Using optical microscopy, we can confine several Cyanobacteria to the limited illuminated area. As we track bacterial trajectory, we can see that it does not escape this illuminated area, because Cyanobacteria will simply starve in the darkness, whereas light brings food and energy. More and more bacteria can be confined using light, and all cells will move towards the light source. Naturally, the cyanobacterial amount increases near the food source. This makes them aligned alongside each other. This alignment can be explicitly seen using the fluorescent microscopy. Follow my channel, as I am going to tell you more about different types of microscopy in my future videos. So, if we control the shape of the light source, we can control the pattern in which cyanobacteria will be assembled. So, it means that if we choose the arbitrary pattern of light, cyanobacteria can be assembled in a similar arbitrary pattern. Arbitrary pattern sounds like a definition of painting to me. So, why don't we create the most famous painting ever using cyanobacteria? No, not this one! I meant Mona Lisa! Not to confuse cyanobacteria, let's make Mona Lisa in two different colors, only black and white. The bacterial cells will move towards the white color. Let's make big enough petri dish and disperse there some amount of cyanobacteria cells. Let's put this petri dish onto a tablet or a computer screen with the projected Mona Lisa shaped pattern on it. As times go on, cyanobacteria move towards light, and in a couple of days they create a very well-defined colony with this famous pattern. What do you think about that, Leonardo? This is how we paint Mona Lisa in 21st century. This type of painting is called Cyanograph. As we magnify this Mona Lisa smile in 100 times with fluorescent microscopy, we will see a nicely aligned layers of cyanobacteria cells. Scientists have shown that it is possible to paint with other bacteria species too. Remember, if we think in terms of big picture, our imagination and creativity will have no limits, and I think this is important to develop this quality as we go exploring new worlds outside of our solar system and potentially meet an extraterrestrial life. Because what if alien approach to art is completely different from ours? What if they use different bacteria cells instead of paint to create their paintings? What if instead of green or red color they use different bacteria cells such as Cyanobacteria or Serratia marsansis? This is just something to think about, as we never really know what to expect when we finally go up there. So let's bring innovation and novel way of thinking as we elevate our humanity to the new way of advancement.